Hey guys, welcome to Section 5, Chapter 7 of the Algebra 1 program. And in the next two sections, we're going to go back to our graphing. So we're going to use the skills that we learned in graphing linear equations, and now we're going to graph linear inequalities. So just for clarity, an equation, remember, is going to look something like y equals x plus 4. Right? And when we were graphing those and looking for our solutions and things like that, we graphed it and it was a line. And when we were looking for solutions, it was the point x comma y of intersection. Okay, so now we're going to deal with inequalities, and it's been a while. But just to remind you, an inequality would look something like y is less than x minus 4. Okay, it's also going to graph as a line, but our solutions are going to be shaded areas. Okay, so let me show you what I mean. I'm going to start by graphing actually this inequality that I just put up here. So you're going to start by graphing it just like you would a line. So imagine that this inequality looked like y equals x minus 4. Okay, so I'm going to start at -4, of course, on my y-axis, and then my slope is 1, right? Positive 1. So I would go up 1 and over 1, up 1 and over 1, up 1 and over 1. Okay, one of the first differences that you're going to see with the inequality is the difference between a dotted line and a solid line. So in the inequality that we used here, it was strictly less than. Notice this inequality sign. It wasn't y less than or equal to x minus 4. It was strictly y less than x minus 4. And because it's strictly less than, instead of using a solid line, I'm using a dotted line, which means I don't want the values that fall directly on the line. I need everything above or below it. Okay, so when you have just the less than or just the less than or just the greater than sign, you need to have a dotted line. Okay, and then the other piece we need to consider is that we want all of the values y less than that. Well, where are those values going to happen? Those values are going to happen underneath this line. So to graph the inequality y less than x minus 4 is going to look like this. Our line is a dotted line, and then I'm going to shade the area underneath the line to represent all of the values that make this true. Now, let me give you an example. Let's pick a point in our shaded area, like here. What is that point? It's 3, -5. I should be able to plug that in to my inequality, and the expression should be true. So let's do that. What I'm posing is that -5 is less than 3 minus 4. Or -5 is less than -1. That's true. So that needs to be in my solution set, and it is. So it works. Okay, if this seems crazy, stay with me. We're going to do another one here. What if I had something even simpler than that, just y less than x? Sometimes these simpler ones cause more confusion, to be honest. Okay, so if we're graphing this, I don't have a y-intercept, right? So we assume that it's going to be 0. So I'm going to start right here at 0. And then my slope again is 1. So I go up 1 over 1, up 1 over 1, up 1 over 1. Of course, remember we learned that trick. We could go down and over as long as we do it in the same fashion. Okay, now again, notice that I don't have an equal to sign. All I have is the strictly less than sign. So again, I'm going to show a dotted line instead of a solid line. Don't worry, I'll do another example with a solid line in a minute here. And then again, I want y less than. And y less than denotes the values underneath the line. All right, now as a check, let's check the point 0, 0. And I'm using 0, 0 because 0, 0 is on the dotted part of the line, which means it should not be included in our solution set. So if I put in 0, I'll get 0 plus 0, and 0 is less than 0. But this is not true. 0 is equal to 0. So therefore, that point 0, 0 should not be in our solution set, and it's not because it's on the dotted line. Okay, let's do another one. Let's do y greater than or equal to negative 6x plus 5. Okay, so now I'm going to start at 5 up here on my y-intercept. And my slope is negative 6. Well, my graphs are kind of small, so instead of going up and to the left, which is where I would normally go, I'm going to go down 6 and to the right. 1, 2, 3, 4, 5, 6. And over here, and I'll almost get one more in. 1, 2, 3, 4, 5, 6, and over 1. All right, now I'm going to take my ruler. I'm going to attempt to line this up, which is trickier than it appears, to be honest. All right, now look at this guy. Now I have an equal to sign. The equal to means I want all of the values on the line as well. So this time I'm going to have a solid line. Solid line is when we have an equal to in our expression. A dotted line is when we don't. And now I want all of the values greater than y. And that's going to be denoted above the line. Now these are a little bit trickier when the lines are pretty steep. Like how do you determine when it's above and when it's below? So again, if you're uncertain, we can always do a checkpoint. I like to use 0, 0 when I can because those numbers are so easy to work with. And according to our graph, 0, 0 should not be in the solution set. So let's see. So we have 0 greater than or equal to negative 6 times 0 plus 5. 0 is greater than or equal to 0 plus 5. 0 is greater than or equal to 5. This is not true. So 0, 0 better not be shaded. And in fact, it's not. Okay. Now, most of these are going to be solved for you in terms of y is greater than or equal to. But of course, every once in a while, we're going to throw in something where you have to do the work. So what if I had 2x plus 3y is less than or equal to 6? So now I have to solve this guy for y first before I can graph. Hopefully, we're feeling very good about those steps. I'm going to subtract 2x from both sides. And then I'm going to divide by 3. Negative 2/3 x plus 2. Remember, I'm dividing every piece by 3 here. So that's 3 and that's 3, just in case you need a little reminder. All right, and now I'm ready to graph. So I'm going to start at 2 on the y-axis here. And my slope is up 2 over 3, but it's negative, right? So up 2 to the left 3, up 2 to the left 3, or you could go down 2 and to the right 3. Now, take a look at this. We have an equal to sign. That equal to sign means I need a solid line going through my points. And then I want the values y less than, which denotes underneath the line. Make sure that these problems, as you're working them out, are very clear. It's important that you clearly denote whether your lines are dotted or not, and whether which shaded region you're using for your answer. Otherwise, we're going to count it wrong, so be really clear. Okay, I'm I'm going to do one more problem here for you, and then I think you're going to be ready to go. Hopefully you don't find these too tricky. You mostly know how to do these already, so we should be good, but just a great reminder for you here. All right, so let's solve this guy for y in good fashion. So negative 5y is less than or equal to negative 3x plus 10. Now, I specifically chose this problem to end with because I wanted to remind you about something when it comes to inequalities. Remember that when we multiply or divide by a number when dealing with inequalities, we have to flip the sign. Most students have forgotten that by this point. So right here, as I divide everybody by negative 5, this inequality becomes greater than or equal to. The x value here becomes a positive, and this becomes a negative. So be very careful with those inequalities. There's a couple of just little steps here that we need to make sure that we're paying attention to. So if you multiply or divide by a negative, flip the inequality. That's still true. And now we're ready to graph. All right, so we start down here at negative 2. Now we have a positive slope, 1, 2, 3, 1, 2, 3, 4, 5. And I'll go down, 1, 2, 3, 1, 2, 3, 4, 5. Now, the question is, see if you can answer this. Is it a dotted or a solid line? Hopefully you said solid. I'm like in a vacuum, so you know, I pretend to talk to myself. All right. Now, the question is, do we shade above or below? In this case, we want y greater than this value. So greater than is going to be denoted above the line and shade in something pretty there. Hey, if you're colorful, this is a great time to use a variety of colors. And my shading is, you know, subpar in a lot of fashions, but this really denotes all the way up. This should go on forever up there. So let's check it. Let's check 0, 0. Now 0, 0 should be in my solution set here, right? Because it's shaded. So this better work. So 3 times 0 minus 5 times 0 less than or equal to 10. You could have used this one too, FYI. You could have used either equation to check this point. You get 0 minus 0 is less than or equal to 10. 0 is less than or equal to 10. Yes, of course it is. So you should be good to go here. All right, that is it for this section. You guys make sure that you finish up your notes, read through the section, and begin your assignment.